A rectangular pool measures 30 meters wide by 40 meters long by 1.5 meters deep. The dog starts at one corner of the pool and walks along the two adjacent sides of the pool at a constant speed until it reaches the diagonally opposite corner. So part A, explain whether the dog's average speed or the magnitude of its average velocity must be greater, and describe under what circumstances the two quantities could be equal. So we'll start just by putting down the basic definitions of speed and velocity. We know speed is equal to distance divided by time, and we know the average velocity is equal to displacement divided by time. So the first thing that is important to note is that both of these equations depend on time, and time is going to be the same whether we're looking at speed or velocity. So because the time is the same, all we have to do is compare the distance with the magnitude of the displacement. So we know that displacement is a straight line between 2 points. So in the case of the dog walking along the two sides of the pool, if it goes this way followed by this way, the displacement would just be a straight line from start to finish. So the sides of the pool are 30 meters and 40 meters, and the displacement is going to be shorter than the distance of 30 plus 40. To give the circumstances under which the two quantities would be equal, the only way that the distance would be the same as the displacement is if the dog walked in a straight line. So if you just mentioned something about when it's walking along just one side of the pool, or if you mentioned something about it moving from one corner to the opposite corner, like somehow, like maybe like swimming in a straight line directly across the pool, as long as you mentioned something about a straight line, you would get credit for that. Part B, calculate the dog's average speed if it takes 20 seconds to walk the two adjacent lengths of the pool. So V is equal to delta x over t. Remember, V represents speed or velocity. And in this case, we're talking about speed. So the delta x in this case would represent the distance. So distance over time. The distance is the length of the actual path. So 30 meters plus 40 meters. That gives you the distance of 70 meters divided by the time, which was given in the problem as 20 seconds. 70 divided by 20 is 3.5, and that has units of meters per second. In part C, calculate the magnitude of the dog's average velocity during the same time interval. So, same equation, V equals delta x over t, only this time the delta x represents the displacement. So if you look back at this triangle, you can see that because it's a right triangle, you can just use the Pythagorean theorem to solve for this hypotenuse. Or if you recognize it as a 3, 4, 5 triangle, you would know that this side of the triangle is 50 meters. So the displacement we can plug in as 50 meters over 20 seconds, and that gives you an answer. The average velocity is 2.5 meters per second. In part D, the question states that the dog walks at a constant speed. Does that mean that the dog's velocity must also be constant? Since velocity is a vector, it consists of both a magnitude and a direction. The magnitude of the velocity is the speed, which that part is constant. So the dog doesn't actually slow down at any point. Even when it turns the corner, it's still moving at the same speed the whole time. But the fact that it just changed direction, even without slowing down, means that the velocity is not constant, because the velocity was originally the 3.5 meters per second going to the north, followed by 3.5 meters per second going to the east. So with that speed of 3.5 meters per second, the magnitude part, the velocity went from north to east, so that was not constant.